Section 8.1, solving quadratic equations by two methods, square root method and completing the square method. Quadratic equations, they have this general form, ax squared plus bx plus c is equal to 0, where a, b, c are constants, and this equation, when you have a 0 on the right side, it's called standard form. So first, let's do a few examples based on square root method. Square root method goes as follows. Remember, radicals undo exponents. Is that right? So to get rid of the power of 2, I'm going to take the square root of both sides. Why do I get the square root of both sides? Because x has a power of 2. And the square root has an index 2. These guys cancel. The only problem is, based on the principle of square root, you don't get x, you get absolute value of x, and this guy is equal to 10. Remember way back in chapter 2, when equation has an absolute value, you drop the bars, attach plus or minus. Therefore, the solutions for this first problem is plus or minus 10. In other words, that's our x. So if you raise negative 10 or positive 10 to the power of 2, you get 100. And because these are quadratic equation, the word quadratic means what? Second degree. Okay. So that means we have to have what? Two answers, rain or shine. Okay. Two answers. So positive 10 doesn't cut it. It's the other answer is negative 10 as well. What about this guy? The first thing I do is what? Add 45 to both sides. So you get x squared equals 45. You take the square root of both sides like so. But that would give you absolute value of x equals 9 times 5, which is absolute value of x is 3 square root of 5. Now that you simplified the radical, drop the bars, attach plus or minus to the right side. So the solutions are what? Either negative 3 square root of 5 or what? Positive 3 square root of 5. Do you all see it? Yeah? Sometimes expect, now that we have gone over complex numbers, expect the roots to be complex. In other words, the roots might be imaginary. For instance, in this problem, if I subtract 49 from both sides, I get x squared equals negative 49. But if I take the square root of both sides, notice I have a negative number under the square root. So the left side is absolute value of x, but the right side is not 7, nor is negative 7, is 7i. So now I drop the bars, attach plus or minus to the right side, so the solutions are what? Either negative 7 or what? Positive 7i. So expect in this chapter to get what? Complex roots as well. The next problem is x plus 3 squared plus 25 equals 0. So subtract 25. So you get x plus 3 squared equals negative 25. So isolate the square term and then take the square root. Okay. And when you do, once again, notice I have a negative number under the square root. So I'm going to get absolute value of what's under the radical, and that guy is 5i. Do you see it? Square root of negative 25 is not negative 5, it's 5i. Drop the bars, attach the plus or minus 5 to 5i plus or minus, and then subtract 3. So the solutions are negative 3 plus or minus 5i. In other words, you get two complex what? Solutions. Notice the solutions are conjugate of each other. Notice here we got negative 7i, positive 7i. Negative 3 plus 5 square root of I, negative 3 minus 5 square root of y. So the complex roots, they always come in conjugate pair. This guy is pretty much ready to go, except you have fractions. Okay, so take the square root of both sides. On the left side, you get absolute value of 2x plus 1/2. On the right side, the square root of 4 over 25 is 2 over 5. Drop the bars on the left side, attach plus or minus to the right side. So now we got work to do. What is it? Well, right now we need to first, so this is like two equations in one. 2x plus 1/2 sometimes is equal to negative 2/5, and the same 2x plus 1/2 some other time is equal to positive 2 over 5. So you get two possible solutions, two solutions, so you get two possible answers, correct? So let me just do that problem right over here to show you how the solution is going to look like. Suppose I take what? Say I take 2x plus 1/2 equals negative 2/5. So what I do, I subtract negative 1/2. So I get 2x is equal to negative 1/2 minus 2/5. I need LCD, which is 10. Got to multiply top and bottom of this fraction by 5. So you get negative 5. Multiply top and bottom of this fraction by 2. You get negative 4. So you get negative 9 over 10. But then you have to divide both sides by 2. When you say divide both sides by 2, that's exactly the same as multiply both sides by what? Reciprocal, which is 1/2. So 2x is equal to negative 9 over 2, 10. Multiply both sides by 1/2. Is that right? And the final answer, 2's cancel here. You get what? Negative 9 over 20. Okay, so that's pretty much one of the answers. The other one comes from the fact that 2x plus 1/2 could also be equal to positive 2/5. Once again, you subtract to what? 1/2 from both sides. And when you do, what would you end up with? You end up with what? 2x equals 2/5 minus 1/2. LCD is 10. Multiply top and bottom of this guy by 2. This fraction by 5. So you get what? Negative 1 over 10. Multiply both sides by reciprocal of this number, which is 1/2. And these guys cancel, so x is equal to negative 1 over 20. So what are the solutions? The solutions of negative 1 over 20 or negative 9 over what? Where'd it go? 20. There you go. Right? So yeah, you got fractions, so don't panic. Just slowly and but surely try to solve and make sure when you add fractions, you get what common denominator. We should be okay. All right. Back to our section 8.1. The next method is called completing the square. However, completing the square only works if the leading coefficient is 1. So leading coefficient must be positive 1, yes? If not, then you have to divide both sides of the equation by that leading coefficient. So let's see if we know how to complete the square. Completing the square means you get expression. What should you add to that expression to get what? Something is squared. So that's why it's called completing the square. In other words, what should I add to x squared plus 2x to get x plus 1 squared? If you expand this, you get what? X squared plus 2x plus 1. So it looks to me I have to add 1 here. But without knowing this, how would you know what to add? So the idea is the following. You divide what? The coefficient of x, which is b, divided by 2, raise it to the power of 2, which is b squared over 4. This is what you add, what? This is what you add to the equation in order to complete the square. Okay, so in this case, what you do, you take half of b and you square it. That's 1 squared, which is 1. That's what you go. That's what goes inside the box. What should I add to this binomial to get x plus 3 squared without expanding? Once again, take half of the coefficient of x, including its sign, which you get what? Positive 3. Is that right? And then you square it, you get 9. So you gotta add 9. So that missing number was 9. How do you complete the square on the left side? What should I add here so I can change x squared minus 8 into x minus 4 squared? Once again, take half of the coefficient of x and then square it. So that would be like negative 4 squared, which is 16. So that magic number is 16. Here, we got a little problem because the coefficient of x is fractions. So take what? Take half of half. Okay, when you say half of half, half divided by half, right? So let's see what that means. So 1/2 divided by 2. Well, that's the same as half times 1/2, which is 1/4. But then I got to raise this guy to the power of 2, which is 1 over 16. So that magic number, which goes inside this box, is 1 over 16. Did you see how I got it? Half of half is 1/4. 1/4 square is 1/16. Now, if you factor this out, you get x plus 4 to the power of 2. What about this guy? Same thing as before. So take what? So take negative 1/5 divided by 2. So that would be like negative 1/5 times 1/2, which is negative 1/10. Square it. You get positive 1 over 100. So that missing number is 1 over 100. Because if you factor this out, you get x minus 1 over 10 squared. Finally, this guy, and notice in all these cases, my leading coefficient is what? 1. If it is not 1, you gotta force it to be equal to 1, right? So negative 7/2 divided by 2, that's like negative 7/2 times 1/2, which is negative 1 over what? 14, is it? But then you gotta square it. That's 1 over, what is this? That's like, what? 14 squared, which is 196. So that magic number, which goes inside this box here, is 1 over 196. Yeah, we see it. Okay, now that we know how to complete the square, let's solve these guys by completing the square method. So make sure the leading coefficient is 1. So what you do is first get rid of this constant. So that will be x squared plus 18x equals negative 15. Okay, make sure the leading coefficient is 1. Then move this constant to the right side. Now take half of 18, which is what? 9. Square it, which is 81. So add 81 to both sides of the equation, correct? You all see it? So now, if you factor this out, you get x plus 9 squared equals, so that would be like what? 81 minus what? 15, that would be like 66. Now, take the square root of both sides, so that's x plus 9 squared equals the square root of 66. Is that right? And now we get what? Absolute value of x plus 9 on the left side, because the 2 wipes out the radical. But then you get the square root of 66. So drop the bars, right? Attach plus or minus. I think a square root of 66 is simplified already. Subtract 9. So you get x equals -9 plus or minus square root of 66. So we should be A-okay. Do you see it? Next one, make sure the leading coefficient is 1. Take half of -6. That would be like what? -3. Square it. And that would be like 9. So first, you subtract 2 from both sides. Okay. Then what you do, you kind of add what? Half of the coefficient of b squared. In other words, add 9 to this side and that side of the equation. Remember, whatever you do to one side, you got to do it to the other side. But if you factor this out, that would be x minus 3 squared, and that would be like 7. Okay, take the square root of both sides, correct? And now on the left side, you get absolute value of x minus 3. On the right side, you get square root of 7. Please do not change this to decimals, yes? So drop the bars, attach plus or minus. Now add 3, correct? So you get x equals 3 plus or minus square root of 7. Sometimes the answers will have radicals in it. Sometimes it would have an imaginary number, I in it, and so on and so forth. Right here, we subtract subtract 13. Make sure the leading coefficient is positive 1. So you get x squared minus 4x equals -13. Now, the question is, what do I add to both sides of this equation? Take half of the coefficient of x, which is what? -2, square it, which is 4. So you get to add 4 to both sides. So if you factor out the left side, that's x minus what? 2 squared. And that guy is negative what? 9. Is that right? Take the square root of both sides. And don't forget, you have a negative under the square root, so expect to come up with imaginary numbers. So square root of -9 is 3i, remember from section 7.7. Drop the bars, attach plus or minus. Now add 2. Okay, so x is equal to 2 plus or minus 3i. So the answers are complex. Right here, you first add 3, make sure the leading coefficient is 1. So you end up with x squared minus x equals 3. Okay, so question is, what do I add to both sides to complete the square on the left side? Well, take half of this guy, half of -1, and then square it, you get 1/4. So you add 1/4 to both sides of the equation. So you end up with x minus what? Oh, what is this? That would be -1/2 squared equals 3 plus 1/4. 3 plus 1/4 is what? 12 plus 1, which is what? 13/4. Is that right? Take the square root of both sides, right? You will end up with absolute value of x minus 1/2 is equal to square root of 13 over square root of 4. Square root of 4 is 2, so this is square root of 13 over 2. Okay, now drop the what? Absolute value bar on the left side. Let me just show you what to do next. So drop the bars, plus attach plus or minus to the right side. Now add 1/2 so you can isolate the equation for x. So x is equal to 1/2 plus or minus square root of what? 13. Is that right? Over 2. Because they have same denominator, sometimes people write the answer as 2. 1 plus or minus square root of 13 over 2. And that would give you the answer for this particular problem. Finally, we got a couple of more problems where the leading coefficient is no longer 1. Can you see it? Cases when the leading coefficient is not 1, so divide both sides by the leading coefficient. So go like this, 4x squared plus 9x equals 9. Divide both sides by 4. Okay, when you do, you get x squared plus 9 over 4x equals 9 over 4. Now that the leading coefficient is 1, proceed with completing the square. Take half of that. So that would be like 9/4 divided by 1/2. Excuse me, by 2. Is that right? That would be 9/2 divided by 2 because I'm trying to take half of this, which is 9/4 times 1/2, which is 9 over 8. But I got to square that. That's 81 over 64. So you got to add 81 over 64 to both sides. Do you see it? So now, if you factor this out, you get x plus what? Oh, let's see now. 9 over 8 squared. Now I need what? LCD, which is what? Okay, which is what? 64. So 4 goes into 64 16 times. Is that right? So that would be like, say, 9 times 16, is that right? 144 plus 81. So that would be x plus 9 over 8 squared, correct? And that would be like, say, 225 over 64. So now that you completed the square, so the next step is what? Take the square root of both sides, like so. On the left side, you get x plus 9 over 8. What? Absolute value. On the right side, believe it or not, you get what? What do you get? You get, let's see now, what's the square root of, what was it? 225, which is 15, of course. And the square root of 64 is 8. Okay, drop the bars, attach plus or minus. And now subtract 9 over 8 from each side, and lo and behold, you get x equals negative 9 over 8 plus or minus 15 over 8. So this is like two equations in one. Sometimes x is negative 9 over 8 minus 15 over 8, or x is negative 9 over 8 plus 15 over 8. So in first case, common denominator is 8, so you get negative 9 minus 15. In the second case, common denominator is 8, so you get negative 9 plus 15. Here you get negative 24 over 8. Here you get, what do you get? You get 6 over 8. Is that right? And here you get negative 3. Up here you get what? 3/4. So once again, as usual, we should always get what? Two answers, correct? Two answers. You all see it? Up here, notice the leading coefficient is not 1, so first thing you do is divide both sides by 2. What does that mean? That means do this. So what you get x squared minus half of x equals negative 5/2. So now you got to take half of this guy. Now that you have the leading coefficient equal to 1, you got to take half of that. So that's like negative 1/2 divided by 2, which is negative 1/2 times 1/2, which is negative 1/4. You square it, you get 1 over 16. So what you do, you kind of add 1 over 16 to both sides of the equation. Half of this guy is 1/4. 1/4 square is 1 over 16. Now the left side factors as what? X minus 1/4 squared. And the right side, I need to kind of find the LCD, which is 16. Got to multiply top and bottom of this guy by 8. That's negative 40 plus 1, which is negative 39 over 16. And that's x minus 1/4 squared. Is that right? Now I take the square root of both sides, like so. Notice I have a, what? Negative under the radical. So this is the square root of negative 39 over square root of 16. But that's what? Square root of 39I over 4, right? But now on the left side, you get absolute value. On the right side, you get a square root of 39 over 4I. Drop the bars, correct? Attach plus or minus to the right side. And now add 1 over 4. It's pretty lengthy here procedure, isn't it? You get x equals 1 over 4 plus or minus square root of 39. I is outside of the radical over 4. But because they have same denominator, sometimes people write the answer as 4, and on top you get plus or minus square root of what? 39I, and that would be the final answer. I hope that helped. Thank you.